Hi guys, and welcome to another video. Today we will be reviewing the Sesamoidean and Pastern ligaments. If you're new here, a quick hello. My name is Julia Walker with Grey Duck Forge, and I make unofficial review videos for the main topics that come up on Farrier certification exams. With that being said, let's dive into this topic. So, for the Sesamoidean and Pastern ligaments, there's a few things that we should know. It kind of depends on what level of the exam you're studying for, but either way, you want to make sure that you're prepared. So, to have a good grasp of this topic, you should be able to recognize all of the usual names for each structure, as well as where they're located at the pastern, the bones they attach to, and as needed, what they do. The trickiest part of this topic for people tends to be differentiating the main sesamoidean ligaments, so we're going to start there. We're basically going to start with the most external structures, or superficial structures, and work our way closer to the bones as we go, so kind of that way. First up, we have the Y ligament, called that because it's kind of shaped like a Y. It's also called the superficial sesamoidean ligament because it's closest to the skin, and it's called the straight sesamoidean ligament because it's the longest/straightest one. A general trend that we're going to observe is that the longer sesamoidean ligaments are closer to the skin, and they get shorter as we go deeper. The Y ligament attaches to the bottom of the proximal sesamoid bones up at the fetlock, and reaches down past the long pastern bone and attaches to the back and top of P2 because it's long. Next we have the V ligament, called that because it's V-shaped. It's also called the oblique sesamoidean ligament since it reinforces the sesamoids in an off-center way. Picture your oblique abdominal muscles. The V ligament follows a similar shape. It's also known as the middle sesamoidean ligament because of the three main sesamoidean ligaments. It's the one in the middle. And it connects the bottom of the sesamoid bones to the far end of P1. So it starts at the same place the Y ligament does, but it doesn't reach down quite as far. The last main sesamoidean ligament is called the X ligament because, you guessed it, it's shaped like an X. It's also called the cruciate sesamoidean ligament. The word cruciate refers to a cross, like how the crucifixion was on a cross, and a cross is just an X that's been rotated a little bit. So cruciate, think cross, think the letter X. Another name for the X ligament is the deep sesamoidean ligament because relative to the Y ligament and the V ligament, the X ligament is the deepest. It connects the bottom of the sesamoid bones, again, to the proximal end of P1, crisscrossing in the process. That makes it the shortest sesamoidean ligament between the three, the Y, V, and X ligaments. So here we go with a quick review, with pictures and the three important names all arranged in a way that helps compare them. You're welcome to save this for your references. Remember that the letter names are based on the basic shape of each sesamoidean ligament. Straight, oblique, and cruciate are also describing the shapes in more formal ways. So top two are shape words. And then superficial, middle, and deep describe their locations relative to each other. There are three more sesamoidean ligaments that we should be aware of, however. We'll go into them now. And the first up is the short sesamoidean ligament, which are the smallest ones in the group, as well as the deepest. These connect the bottom edges of the proximal sesamoids to the very top edge of the backside of P1, adding a little more reinforcement without the crisscrossing feature of the X ligament. These ligaments are super tough, like wire, and may have frustrated you in a dissection in the past. It's kind of annoying that these aren't called the deep sesamoidean ligament, because they are the deepest one kind of in that area, but they are, most importantly, the shortest ones, so they're called the short sesamoidean ligament. Then we have the intersesamoidean ligament, which is a super tough bundle of ligament fibers that sews the proximal sesamoid bones together. When dissecting a fetlock, this is usually the last ligament that you cut to separate the sesamoid bones, and it usually doesn't feel like it's worth the effort. It can sometimes be hard to see where the intersesamoidean ligament ends and the bones begin. It provides an important function, though, which is why it's so robust. It forms a protective coating/channel for the DDFT to course over the fetlock and the sesamoid bones, so it has to withstand some crazy forces. Also, no other structure truly holds the sesamoid bones together. Every other ligament keeps them from either falling sideways off the sides of the leg or from sliding up the back of the leg. This thing alone holds them together. Lastly, we have to mention the collateral sesamoidean ligaments because, of course, there's some collateral ligaments here. They have a rather unusual shape since they're connecting 3 bones at a time instead of 2, so they form a vaguely triangular shape. However, interestingly, they provide another very important function besides the usual function of a collateral ligament, which is that they anchor the branches of the suspensory ligament as they pass by the sides of the sesamoid bones, trapping the suspensory ligament branches underneath them. So the suspensory ligament comes down the backside of the leg, and it bifurcates above the sesamoid bones, and then wraps underneath the collateral ligaments and then comes around the front. So it goes this way. Cool. So there you have it. We've talked about every ligament of the sesamoid bones. So every sesamoidean ligament. Can you find them all here? If you can, fantastic. They should all at least be partially a little bit visible. Feel free to screenshot this and label the picture on your phone if you want. There'll be more diagrams as we go as well. So now we can talk about the pastern ligaments, the other part of this video. The good news is if you made it this far, you are officially past all of the hard stuff because there are only 2 types of pastern ligaments to tell apart and they are super easy. You might just need to learn how to tell which is which. There are 2 directional terms that you need to know in order to identify them, axial and abaxial. So this diagram on the left here is sort of like if you were a horse and you were looking down at your front hooves, these are the directions we're talking about. So axial on the left refers to things close to the center towards the axis. So coming in towards like the bones basically in a leg. And an axis, in case you don't know, is just an imaginary line that runs through the center of an object. So like Earth rotates on its axis, which runs through like the North Pole and the South Pole. Cool. Abaxial is the opposite of axial, and it just refers to things that are set apart from the central axis of an object. So away from the center. Think about how the word abnormal means something like outside the realm of normal or beyond normal. So, for example, the continents of the Earth's crust are abaxial to the Earth's axis. So knowing all of that, we have 2 types of pastern ligaments. The axial, in purple, pastern ligaments, and the abaxial pastern ligaments. So here we have it, a combined diagram that shows, in one view or another, all of the sesamoidean and pastern ligaments as drawn by me. Feel free to save/label this diagram as well, or save it for quizzing yourself later. We'll run through it really quickly. So this one is the Y ligament, this is the V ligament, this light green one is the X ligament, the yellow one is the short, purple are collateral, this red one is the inter-sesamoidean, and then we've got the pastern ligaments, so axial pastern ligs and abaxial. Wonderful, and that's it. If you can do that, fantastic. So now let's review. The pages I referenced for this video are listed up top for you if you want to take a quick read of the source material after watching this video. First up, I just reminded you that the order from outside to inside of the 3 main sesamoideans is Y, then V, then X. So that is something you should probably just memorize. This is not in alphabetical order, so please don't make that mistake. The letters are just telling you the shape of the ligament. So, question 1. The blank pastern ligament is closest to the center of the leg. So now we're talking about pastern ligaments. We just went over these. Closest to the center, that is the axial pastern ligament. 2. The V ligament is also called the blank or blank sesamoidean ligament. So you need one name for its shape, other than V, and a name for its position. So the other 2 names are the oblique, and then for position, the middle sesamoidean ligament. Great. Number 3, the cruciate sesamoidean ligament is also called the blank or blank sesamoidean ligament. So a letter and a location. Cruciate, cross, X ligament, location, deep. The superficial sesamoidean ligament is also called what other 2 things? It is the Y ligament or the straight sesamoidean ligament. Number 5, which sesamoidean ligament forms a surface that the DDFT passes over? That is the intersesamoidean. And last but not least, which sesamoidean ligament holds in the suspensory ligament? They're the branches of the suspensory ligament, but there's 2 of them, and they are the collateral sesamoidean ligaments. So here you go, a nice, neat answer sheet. Save it if you wish. Do whatever you want. And with all that, we've finished reviewing the sesamoidean and pastern ligaments. Great work sticking in there. I know it's pretty dense. That's also my last video on tendons and ligaments for now. But if there's any other topic you'd like to see covered in a future video, go ahead and leave a comment, and I'll see what I can do. I'm hoping to make some videos with a physical model as well, potentially, to help show how things all go together, but I don't know how I'd film it or plan it out yet, since it's not really my wheelhouse. More on that hopefully to come in the future, but I am thinking about it. The next section I intend to tackle is going to be pathologies, starting with the most important part for our exams, the AAEP lameness scale, so stay tuned for that future video. If you noticed any inaccuracies in today's video, as always, please let us know down in the comments, and if you have anything else you'd like to add, feel free to do that as well. I'm sure any thoughts or contributions would probably be helpful to people watching, and to me as well. So, best of luck in your studies, good luck in your exams, and as always, stay tuned for more.